Hi everyone, I'm Dana and welcome back to Inverter Always. So in today's video, we're going to be continuing part 2 of the installation series for Daikin VRVS. In the last video, we got through product and technology. I wanted to cap that video because it was already getting a little bit lengthy. The goal of this series is to give you guys short 20-minute or less videos to give you bullet by bullet explanations on how to design, things to consider, the meat and potatoes when you're installing Daikin VRVS. So in today's video, we're going to talk about combination ratios a little bit. I think we talked a little bit about it in the last video. We're going to talk a little bit about it more today. We're going to get into unit sizes, sizing, that discussion in general. If there's time, we'll talk about the indoor unit options that you can select from. But depending on time, I might be pushing that into episode 3. So we'll just see how it goes. Again, I want to keep these as short as possible for you guys. So if you enjoyed today's video, please click the like button below. It really helps out my channel. We're trying to grow. We're trying to get to 1,000 subscribers. So if you guys haven't already, please consider subscribing. That also helps out my channel greatly. I hope you guys enjoyed the video. So without further ado, let's go ahead. Let's jump right in. Now, you guys, before we get started today, I just wanted to reiterate, in case you didn't hear me before, or in case I haven't already mentioned this, this is not a factory authorized training. This is not a training in any way, shape, or form. This is just a discussion. I wanted to get you guys the important bullet points, the important information pulled from my experience and discussions and past trainings, the installation and operation manuals, things from the engineering and service manuals, really just give you guys the bullet points, give you guys the breakdown, the things you need to know, the things you need to look out for. This is not a training, and I just want to make sure that I make that clear. So now that you guys know the minimum number of indoor units you can connect and the maximum number of units you can connect to each of the outdoor units, I want to talk about capacity and what we call combination ratios. So the combination ratio is the ratio of indoor unit BTUs being connected to your outdoor unit and what the capacity of that outdoor unit is. For example, we can connect at least 50% to any of these 3 outdoor units, and at most 130%. So on a 3-ton outdoor unit, a 3-ton outdoor unit is rated at 36,000 BTUs. I can connect at a minimum 18,000 BTUs, which is that 1.5 ton indoor unit. And I can connect all the way up to about 46,000 BTUs, just shy of 4 tons. I can't quite fit 4 tons of indoor capacity on a 3-ton outdoor unit. Now, before we talk about the 4 and the 5-ton unit and what they can do, this really is an important point during the design. This is a discussion you guys should be having internally within your companies on, how much you're going to allow yourselves to do. To give you some examples from my market is a very mild market in the grand scheme of things compared to some of the areas where you guys live. The Western Washington, the Pacific Northwest is very mild. Our winters don't get overly too cold and our summers don't get overly too hot, with the exception of 1 week at the bottom of the spectrum and 1 week at the top of the spectrum. The rest of the year is pretty darn mild, most years. We're not having the Arizona heat, the Florida humidity. It's pretty mild here. So we will, in many cases, overconnect our outdoor units. Now, what that means is I might have a 3-ton outdoor unit with 3.5 tons of indoor capacity physically connected to that outdoor unit. For this example, let's just say I do a 2-ton indoor unit and a 1.5-ton indoor unit. That's 3.5 tons on my 3-ton outdoor unit. What happens in normal operation with this type of a configuration is my outdoor unit is rated at 36,000 BTUs, which means it's going to give the indoor units 36,000 BTUs. That is its capability. It does not have the capability to give you more than what it's rated at. It can give you 3 tons. That's all you get, and that's in normal conditions. We're going to call normal conditions 55-degree outdoor temperatures for now. Because I have 3.5 tons of indoor load, I am designing around the fact that I will never need 3.5 tons of capacity inside the house. I may need, at one point, a full 2 tons from my 2-ton unit, but when I need 2 tons from that unit, I don't need 1.5 tons from my other unit. The other unit is either off, it's satisfied, which we call thermo off, it's not calling, or maybe it's 1 degree from set point and it's only calling for 9,000 BTUs. It's not calling for the full load. Now, in a application where the homeowner has been educated on how to use this system, neither of these 2 indoor units should be calling for full load. You should never be calling for full load. So the idea here is at any point in time, I may need a little bit more than the other zone. As long as the house, the block load, the overall load isn't calling for more than what my outdoor unit can deliver, then I'm good. The problems that I see, the problems that you're going to run into is when you do a mini split multi-zone system and you simply look at the combination charts on the submittal and it says, oh, I can put 4 1-ton wall heads, that's 4 tons, on a 3-ton outdoor unit, so I'm going to do that. Dude, if you need 4 tons in the house, you need to do a 4-ton outdoor unit. You can't undersize the outdoor unit thinking that, oh, well, it'll give me 4 tons of capacity. That is not how it works. And I might seem a little triggered here, so I'll digress. But this happens time and time again, and then we get the call every winter or every summer. Why is it not keeping up? Well, it's not keeping up because you have 4 tons connected to a 3-ton outdoor unit, and you're calling for 4 tons. Your house needs 4 tons. And not to mention, in the winter, these units will derate below freezing. So if it's 20 degrees outside, you're not going to have the full capacity of that outdoor unit available in the first place. So now you're really connected even more than 130%. So no matter what you do, you need to design each of your indoor units for the space they're serving. If the space requires 2 tons, you're going to put a 2-ton air handler or 2-ton wall mount or 2-ton cassette, whatever style, doesn't matter. If the space needs 2 tons, you put in 2 tons. If this other space needs 1 ton, you put in 1 ton. If there's a third space that needs 1 ton, then put in a 1 ton. That's 4 tons. Put a 4-ton unit outside. That way you're covered. That way you're not going to be running into the problems by putting in a 3-ton outside. Technically speaking, on VRV systems, 4 tons, 48,000 BTUs is more than 130% to begin with. So you're already going outside of the design parameters and you're going to increase your risk for having problems. I don't recommend it. Okay, there is no need to try to downsize that outdoor unit. If the house only needs 3 tons, but maybe you're going to upsize a couple of your indoor units because you need a little bit more CFM to the spaces, well, that's another conversation. BTUs for BTUs, you don't really want to be overconnecting that much. You have to be careful when you're sizing your equipment. Now, I won't go into any more detail about that. I think you guys get the idea. But this is always a really good conversation piece in the class. So if you guys have questions about sizing, I can't help you as far as doing load calcs go. You should always be doing a load calc on the house so you know the sizing that you're selecting is going to be appropriate for that home. I'm also going to lean on the conservative side always. I would rather have a little extra available than not enough. Your unit, for example, might have 3 tons full capacity at 40 degrees outside, 35 degrees, 32 degrees, but then it's going to start derating. And before you guys say, well, what about the Hyperheats? What about the Daikin Auroras? Every manufacturer has their own unit that provides full heat down to 0 is a total gimmick. All it is a larger compressor. So the 1-ton Aurora or the 1-ton Hyperheat has a 1.5-ton or a 2-ton compressor that they pre-derate from the factory as a 1-ton unit. So that way, when it drops down to 0 or 5 degrees, whichever manufacturer says, so Daikin says down to 5, Mitsubishi I think says down to 0, whatever, it's really a 2-ton unit that has derated all the way down to 1 tons. Generally, if you look at any normal unit, the derated amount at 5 degrees for Daikin is about 60% capacity available compared to the normal sizing. So a 3-ton unit is going to have at 5 degrees outside a little over 1 ton of capacity. And this is true for pretty much all of the different compressor sizes throughout Daikin's single-phase product lineup. When you buy the Aurora that says, well, we have 100% heat down to 5, it's actually a larger compressor that they derate at the factory to be a smaller unit cabinet. So that way, when it gets down to 5, it still has 1 ton of capacity. The compressor itself was more than likely a 2-ton compressor, for example. And you can check this in the engineering manuals. If you go to about a 55-degree outdoor temperature, you can see what that compressor's capacity is. And that is generally pretty close to the size of the compressor. So fun fact, kind of deviated from the conversation a little bit, but basically sizing is super important. You guys want to be careful and just make sure you cover your butts. So the 3-ton unit can have minimum 50% connected. That's 1.5 tons up to a maximum of 46,000 BTUs. But again, just because you can doesn't mean you should. And that's going to be the first piece of merch that we get when we hit 1,000 subscribers, and I can actually have the merch store open and offer you guys cool merch products and etc. So just because you guys can do something in the inverter world doesn't always mean you should. The 4-ton unit, you can have minimum 50%, maximum 130%. So a minimum of 2 tons can be connected all the way up to just over 5 tons, 62,000 BTUs. The 5-ton unit, you got to be kind of careful with here because the 5-ton outdoor unit is actually rated at 57,000 BTUs, not 60,000 BTUs, which means that if you connect minimum 50%, it's 28,000 BTUs. If you do a 2.5 ton, you're covered. But on the high side, guys will do this all the time. They'll go and they'll try to connect 78,000 BTUs. That's 6.5 tons of indoor equipment to a 5-ton outdoor when the max is actually 74,000 BTUs. You have to take 57 times 1.3. It's not 78,000 BTUs. Now, people will always ask, what happens if I do it anyways? You're just increasing the risk for problems. That's all I can say today. Are you going to get an error code? You will get an error code if you don't connect at least 50%, but you will not see an error code, at least not today, if you connect more than 130%. But again, just because you can doesn't mean you should. You're going to get 57,000 BTUs out of that outdoor unit, period, in a normal condition. It will then derate when it gets below freezing. How far it will derate will be dependent on the outdoor conditions, the length of your line set, because that always also has a factor in the derated amount. So you have to be careful. Size your indoor units and outdoor units appropriately. When you're sizing your indoor units model nomenclature, for example, the FXAQ07, it's a wall mount, is a 7,000 BTU wall mount, but it technically is rated at 7,500 BTUs. You have to take the 7,500 BTUs into the sum of indoor unit loads when you're doing the math. You can't take a 7 and a 7 and call it a 14 because 7 and 7 each have 7,500 BTUs rated, which is 15,000 BTUs. And at the end of the day, that 1,000 BTUs will make a difference. So you need to be careful. The 5s, so your FXZQ, FXSQ05s, same thing, but they're 5,800 BTUs. And then your 9s are the same as 7s, so 9,500 BTUs. It's not until you get to a 1-ton unit, a 12,000 BTU indoor unit, that now a 12 is a 12, a 15 is a 15, an 18 is an 18, a 60 is a 60, etc. So you do need to be careful about that. That is extremely important. All right, you guys, so I'm going to go ahead and I'm going to cap us off here for today. Lots of discussion on sizing, and I don't want to get into unit selection until we get a little bit of a break. Lots of information to process. So again, if you guys have any questions about anything we've talked about so far in the series, please don't hesitate. Put them in the comments below. I love the engagement. You guys ask good questions all the time. So please, anything that comes across your mind, Daikin VRVS related, of course, put them in the comments below. I do read all of your comments and I always do my best to respond. You guys, if you enjoyed today's video, please click the like button below. It really helps out my channel as we're trying to get to that 1,000 subscriber mark. If you haven't already, please consider subscribing. You guys, thank you so much for tuning in again today. Thank you for watching Inverter always. I hope you have an awesome day.